Hello everyone. Welcome to the solution of LeetCode problem 2009 named minimum number of operation to make array continuous. In this problem, you are given an integer array nums and in one operation, you can replace any element in nums with any other integer. Now, the array is considered continuous if both of the following conditions are fulfilled. The first condition is all elements in the array are unique and the difference between the maximum element and the minimum element is equal to array length minus 1. For example, 4253 is continuous. Why so? Because the maximum element is 5 and the minimum element is 2 and their difference is 3, which is equal to the array size, which is 4 minus 1. But unfortunately, this array 1, 2, 3, 5, 6 is not continuous because the difference between 6 and 1 is 5, which is not equal to the array of length minus 1, which is 4. So here we have to return the minimum number of operations to make the array continuous. Now, for the first example, 4253, it is already a continuous array, so the minimum operation is 0. And in the second example, the array contains 1, 2, 3, 5 and 6, these elements. And here, if we change the last element 6 to 4, then the array will become 1, 2, 3, 5 and 4. So here the maximum and minimum difference will be 5 minus 1, which is 4, which is the array of length minus 1. So here we have to perform minimum of 1 operations. I hope you understood the problem statement. Now let's move on to the algorithm. Now, to solve this problem, we are going to use the binary search technique, basically the upper bound. Initially, we have to know what is the upper bound. Suppose for this array, what is the upper bound of 5? So here, this element 5 remain here. And if we insert any element 5, it will be inserted after 5. And 6 will be here. So the upper bound of the 5 will be the index 4. Here, the upper bound is the last appearance of an integer and its index number. This is a basic definition of the binary search upper bound. Now, let's see how can you solve this problem by using the binary search technique. So here, the intuition is very simple. We have to iterate each of the elements from left to right. And for each of the elements, suppose 1, 2, 3, 5, and 6, we have to make this element as the minimum. And what is the maximum of 1? It will be 1 plus 4, which will be 5. And for each of the element, we have to consider the array element as the minimum and make the maximum value this. And if by making this maximum value, we have to check how many elements presented in the array in this range. Suppose here, 2 of the values presented in this range. That means we have to manipulate 5 minus 2, the 3 of the value. And by doing these operations in all of the element, we have to simply calculate the answer. Anyways, let's dry run the example. At first, we are at this element 1. Now, the minimum of the element is 1. And what will be the maximum? It will be 1 plus 4, which is 5. Now, we have to find the upper bound of the element 5 in the array. So here, the upper bound of the 5 is 4. And the corresponding position is here. So how many value presented in the range of 1 to 5 in this array? It will be the upper bound, which is 4 minus the current type, which is 4 minus 0, So the value presented here is 4. So now we need to manipulate 5 minus 4 element. That means one element to make the array continuous. Why so? Because let's see, for the range 1 to 5, these elements are presented 1, 2, 3, and 5. Now, if we make this 6 to 4, that means we have made one operations, then the array will become continuous. In those cases, 1 and 5 and their difference will be equal to 4. So here, for the range 1 to 5, the value presented is 4 and the operation needed is 1. Similarly, for this element 2, the range will be 2 to 6. And what is the upper bound of 6? It will be the index 5 because we can place another 6 here. Now, the value presented will be index 5 minus current index, which is 1, which is 4. So here the value presented 4 and the needed operation will be 5 minus 4, which will be 1. Now we are at this position 3. So 3 will be the minimum value. So what will be the maximum? The maximum will be 7. And what is the upper bound of 7? The upper bound of 7 will be 5, which is this position. Now, how many value presented in the range of 3 to 7? It will be 5 minus 2, which will 3. That means this 3, 5, and 6. So here we have to perform 5 minus 3 operations, which is in total 2 of the operations to make the array continuous. Now we are at this element 5 and the upper bound will be 9. Similarly, the upper bound of 9 is 5 and current index is 3. So in total, there are 2 value presented in the range of 5 and 9, which will be this 5 and 6. So there are 2 value presented and the operation needed will be 5 minus 2, which will be 3. Now here, for the last element 6, the upper bound will be 10. And here only one element presented in the range of 6 to 10. And we have to perform the 4 operations, which is 5 minus 1, which is 4. So now, by utilizing the needed operation, we have seen that the minimum operation is 1. That means if we convert this 6 into 4 by doing one operation, then the array will become continuous. And the overall time complexity of this problem is big O of n log n. Here, big O of n is for the iterating all of the element, and inside them, we have to find the upper bound. That's why we have to perform the log n operation. That's why the overall time complexity of this problem is big O of n log n. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named minimum operations, which has a vector as a parameter. Now we are initializing n with the a of size and answer with n. Now we are applying the sorting operations because to perform the binary search, we have to make the array sorted. Now, this is one of the necessary operation. We are excluding the duplicate value and we are only maintaining the unique value here. Now, we have to run a loop from 0 to n. And here, what will be the maximum element? It will be a of I plus n minus 1. And what will be the minimum element? It will be a of I. Now we are calculating the upper bound of this maximum element, and we are checking how many presented unique element here in our array, which will be upper bound minus I. Now the required operation will be n minus the presented unique element. Now the answer variable will be minimum of answer of required operation. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.